When upgrading an electrical service, there are several code requirements to consider. Firstly, the National Electrical Code, NEC, Section 220.82 stipulates that residential dwellings must have a minimum of a 100 amp service. Secondly, NEC Section 230.70 requires that the service entrance equipment, including the meter and main panel and any required disconnect, must be separate from all other equipment. The service equipment must be readily accessible and should not be located in a bathroom or any other hazardous location as per NEC Section 230.71. Additionally, all conductors in the service drop must be rated for at least 100 amps, according to NEC Section 230.22. Regarding the subpanel on the second floor, it's essential to ensure it complies with current electrical codes. NEC Section 240.15 mandates that the subpanel on the second floor must be equipped with a disconnect. An upper floor subpanel can be supplied by a single feeder from the main service panel if it meets certain conditions, as outlined in NEC Section 384.20a. The feeder to the subpanel must be sized appropriately for the anticipated load and be protected by a circuit breaker or fuse, as stated in NEC Section 384.16b. Furthermore, the neutral and grounding conductors of the subpanel must be properly connected and sized according to code, adhering to NEC Section 250. To address the existing subpanel situation, several steps are recommended. Rewire the subpanel by replacing the existing number 10 feeder with a properly sized one from the new service panel. This ensures adequate capacity and protection for the circuits in the subpanel. Install a disconnect to the subpanel if it does not currently have one, providing a convenient way to isolate the subpanel from power. Verify that the neutral and grounding connections in the subpanel conform to NEC requirements. Consider replacing the subpanel if it's old or inadequate with a new one that meets current code standards. In addition to these measures, there are several other considerations to take into account. Inspect the knob and tube K and T wiring in the subpanel and throughout the house. K and T wiring can pose safety concerns and may need to be replaced. Verify that the service entrance conduit is sized appropriately for the new service wires and that it does not contain any splices or other defect. Replace the old weatherhead with a code-compliant model and ensure that it is securely mounted to the structure. It is imperative to ensure the service entrance equipment, meter and main panel, and disconnect if required, must be separate from all other equipment. A subpanel on an upper floor can be supplied by a single feeder from the main service panel if it meets certain conditions. The feeder to the subpanel must be sized for the anticipated load and be protected by a circuit breaker or fuse. The neutral and grounding conductors of the subpanel must be properly connected and sized according to the code. Replacing the existing number 10 feeder with a properly sized one from the new service panel ensures adequate capacity and protection for the circuits in the subpanel. Installing a disconnect to the subpanel, if one is not already present, provides a convenient way to isolate the subpanel from power. The neutral and grounding connections in the subpanel should be checked and verified to conform to NEC requirements. If the existing subpanel is old or inadequate, it may be wise to replace it with a new one that meets current code standards. When dealing with existing knob and tube wiring, it is crucial to inspect it thoroughly for any signs of damage or deterioration and to address any safety concerns it may pose. Verify that the service entrance conduit is sized appropriately for the new service wires and that it does not contain any splices or defects. The weatherhead should be replaced with a code-compliant model and securely mounted to the structure. The importance of proper grounding and bonding in electrical systems cannot be overstated. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the circuit breaker or fuse and energize the circuit in the event of a fault. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, which minimizes the risk of electric shock. When upgrading an electrical service, it is essential to ensure that the grounding and bonding systems are properly installed and maintained in accordance with the NEC. This includes ensuring that the grounding electrode system is adequate, that all metal parts of the electrical system are properly bonded together, and that the neutral conductor is properly grounded at the service entrance. The overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. These devices are sized to protect the conductors and equipment that they serve. When upgrading an electrical service, it is important to ensure that the overcurrent protection devices are properly sized and installed in accordance with the NEC. This includes ensuring that the circuit breakers and fuses are of the correct ampacity rating, that they are properly labeled, and that they are installed in a suitable enclosure. The wiring methods used in electrical installations must comply with the NEC. The NEC specifies the types of wiring methods that are permitted for different applications, as well as the requirements for installing and supporting the wiring. When upgrading an electrical service, it is essential to ensure that the wiring methods used comply with the NEC. This includes ensuring that the conductors are of the correct size and type, that they are properly insulated, and that they are installed in a safe and workmanlike manner. Electrical panels must be installed in readily accessible locations and must be properly labeled. The NEC specifies the requirements for installing and labeling electrical panels. When upgrading an electrical service, it is important to ensure that the electrical panel is installed in a readily accessible location and that it is properly labeled. This includes ensuring that the panel is mounted securely, that it is free from obstructions, and that the circuits are clearly labeled. The NEC also specifies the requirements for working clearances around electrical equipment. These clearances are intended to provide sufficient space for electricians to safely work on the equipment. When upgrading an electrical service, it is important to ensure that the working clearances around the electrical equipment comply with the NEC. This includes ensuring that there is sufficient space in front of the equipment, as well as adequate side and rear clearances. Electrical inspections are typically required for electrical service upgrades. These inspections are performed by qualified electrical inspectors to ensure that the work complies with the NEC and local codes. When upgrading an electrical service, it is important to obtain the necessary permits and schedule an electrical inspection. The electrical inspector will review the work to ensure that it meets the applicable requirements. Always remember that electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself from electric shock. This includes wearing appropriate personal protective equipment such as rubber gloves and safety glasses, and working with de-energized circuits whenever possible. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. When dealing with an old electrical system, such as one with knob and tube wiring, it is especially important to exercise caution. Knob and tube wiring is an outdated wiring method that can be hazardous if it is not properly maintained. If you are working on an electrical system with knob and tube wiring, it is important to have it inspected by a qualified electrician to determine if it needs to be replaced. When upgrading an electrical service, you may also need to upgrade other parts of the electrical system, such as the grounding system, the overcurrent protection devices, and the wiring methods. It is important to have a qualified electrician evaluate the entire electrical system to determine what upgrades are necessary to ensure that it meets current code requirements. Always consult with a qualified electrician before making any changes to your electrical system. A qualified electrician can help you to determine the best way to upgrade your electrical service and to ensure that the work is done safely and in accordance with the NEC and local codes. When dealing with an overhead service drop, it's crucial to maintain safe distances. The service wires should be high enough to prevent accidental contact. Local utility companies typically have regulations regarding the minimum height requirements for service drops. Contact your local utility to confirm these requirements before commencing any work. In situations where the service wires are too low, it might be necessary to relocate the service drop to ensure compliance with safety standards. The weatherhead serves as a protective entry point for service conductors entering a building. It's essential to ensure that the weatherhead is installed correctly and is weatherproof. Cracks or damage to the weatherhead can allow water to enter the conduit, potentially causing corrosion and electrical hazards. When replacing a weatherhead, use a code-compliant model designed for outdoor use. Securely mount the weatherhead to the structure to prevent it from dislodging during severe weather conditions. Conduit protects the service entrance conductors from physical damage and environmental factors. When inspecting the conduit, check for any signs of damage such as dents, cracks, or corrosion. Ensure that the conduit is properly supported and secured to the building structure. If the existing conduit is undersized for the new service conductors, it might be necessary to replace it with a larger diameter conduit. Splices within the service entrance conduit are generally prohibited. Any splices should be made in an accessible junction box. The meter and main panel are critical components of the electrical service. The meter measures the amount of electricity consumed, while the main panel serves as the distribution point for electricity within the building. When upgrading the service, ensure that the meter is adequately sized for the new load requirements. The main panel should have sufficient capacity to accommodate all the circuits in the building, with spare breakers for future expansion. The main panel should be properly grounded and bonded to ensure electrical safety. Subpanels are used to distribute electricity to specific areas or loads within a building. When installing a subpanel, it's essential to follow the NEC guidelines for feeder sizing, overcurrent protection, and grounding. The feeder conductors supplying the subpanel must be sized to carry the anticipated load, with appropriate overcurrent protection in the main panel. The neutral and grounding conductors in the subpanel should be properly connected and sized according to code. The subpanel should be equipped with a disconnect switch to allow for easy isolation of the subpanel for maintenance or repairs. Knob and tube wiring is an outdated wiring method that is considered unsafe by today's standards. If your home has knob and tube wiring, it's highly recommended to replace it with modern wiring methods. Knob and tube wiring lacks a grounding conductor, which increases the risk of electric shock. The insulation on knob and tube wiring can deteriorate over time, leading to short circuits and fire hazards. Replacing knob and tube wiring with modern wiring can significantly improve the safety and reliability of your electrical system. A ground fault circuit interrupter, GFCI, is a device that protects against electrical shock by monitoring the current flowing through a circuit. If a ground fault is detected, the GFCI will quickly trip the circuit, cutting off power and preventing injury. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. When upgrading an electrical service, it's essential to ensure that GFCIs are installed in all required locations. An arc fault circuit interrupter, AFSI, is a device that protects against electrical fires by detecting arc faults. Arc faults are dangerous electrical conditions that can occur when wires become damaged or loose. AFSIs are designed to trip the circuit when an arc fault is detected, preventing a fire from starting. AFSIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. When upgrading an electrical service, it's essential to ensure that AFSIs are installed in all required locations. Surge protection devices protect electrical equipment from voltage surges, which can damage sensitive electronics. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices divert excess voltage away from the equipment, preventing damage. It's recommended to install surge protection devices at the main panel and at individual outlets to protect your valuable electronics. Electrical permits are required for most electrical work, including service upgrades. Permits ensure that the work is performed safely and in accordance with local codes. Before commencing any electrical work, obtain the necessary permits from your local building department. Electrical inspections are conducted by qualified electrical inspectors to ensure that the work meets code requirements. Inspections help to identify any potential safety hazards and ensure that the electrical system is installed correctly. Schedule an electrical inspection after completing the service upgrade to ensure that it meets all applicable codes. Always hire a licensed electrician to perform electrical work. Licensed electricians have the training and experience necessary to perform electrical work safely and in accordance with code. They can also help you to obtain the necessary permits and schedule inspections. Attempting to perform electrical work yourself without proper training can be dangerous and can lead to serious injury or property damage. Proper grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Bonding ensures that all metal parts of the electrical system are at the same electrical potential, minimizing the risk of shock. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode should be connected to the main panel with a grounding electrode conductor. Bonding is achieved by connecting all metal parts of the electrical system, such as metal conduit, metal enclosures, and metal appliance frames, to the grounding system. The bonding conductors should be sized according to code. Proper overcurrent protection is essential for preventing electrical fires. Overcurrent protection devices, such as circuit breakers and fuses, are designed to trip the circuit when an overload or short circuit occurs. The overcurrent protection devices should be sized to protect the conductors and equipment that they serve. It's important to use the correct type of overcurrent protection device for each application. Circuit breakers are resettable devices that trip when an overload or short circuit occurs. Fuses are one-time devices that melt and break the circuit when an overload or short circuit occurs. Arc fault circuit interrupters FSIs are designed to protect against electrical fires by detecting arc faults. Arc faults are dangerous electrical conditions that can occur when wires become damaged or loose. FSIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters GFCIs are designed to protect against electrical shock by monitoring the current flowing through circuit. If a ground fault is detected, the GFCI will quickly trip the circuit, cutting off power and preventing injury. GFCIs are required in areas where there is a high risk of water exposure, such as bathrooms, kitchens, and outdoor locations. Surge protection devices are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protection devices divert excess voltage away from the equipment, preventing damage. It's recommended to install surge protection devices at the main panel and at individual outlets to protect your valuable electronics. The National Electrical Code (NEC) is a set of standards for electrical installations in the United States. The NEC is updated every 3 years and provides guidelines for safe and reliable electrical installations. It's important to follow the NEC when performing electrical work. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. Local codes and regulations may also apply to electrical installations. It's important to check with your local building department to determine the specific requirements for your area. Always consult with a qualified electrician before performing any electrical work. A qualified electrician can help you to determine the best way to upgrade your electrical service and to ensure that the work is done safely and in accordance with the NEC and local codes. Attempting to perform electrical work yourself without proper training can be dangerous and can lead to serious injury or property damage. It's important to take the necessary precautions to protect yourself from electric shock when working with electricity. This includes wearing appropriate personal protective equipment such as rubber gloves and safety glasses, and working with energized circuits whenever possible. If you are not qualified to perform electrical work, it's best to hire a licensed electrician.